So this program is a kinematics visualization, and what that means is you're going to input the initial position and velocity of some particles, and it's going to output a graph displaying how those particles are moving over time. So let's take a look at what happens when I run the program. So first thing it asks for is to add a planet, so let's go ahead and do that, and I'm making the planet Earth. And what that means is the acceleration due to gravity is 9.8 meters per second squared. The coefficient of friction for the ground is basically asking how rough the ground is, and that'll tell you how quickly the particles slow down when they hit the ground. I'll put 0.2. Now I'm going to add a particle, and I'm just putting arbitrary values for the x, y, z positions and velocities. But when you use this to solve a problem, you're going to put the values associated with that problem. I'll add another particle. And now I'm going to continue. So we're going to collect data in intervals of 0.1 second. And so yeah, now for the output. The graph is showing us really nicely here where these particles are over time. So the blue dots represent one particle and the green dots represent another particle. And yeah, so what's kind of interesting here is that these particles are following a parabola shape, and I'll explain that in a second. But right here you can see that this is a parametric graph, and what that means is the positions of the particles are being displayed along this x-axis and the y-axis right here. And then there's a little number right next to each dot, and that tells you what time those particles are at that position. And so now let's take a look at the code a little bit. So main.py right here is where the central function of the code is. So all these other files that you can see in these tabs are all going to be connected back to this main file. So I would encourage you now to take a look through main.py, particleclass.py, and graphwindow.py and look at all the comments in there. And that's going to tell you the outline of the code, how each section works, and just give you a basic idea of how you can start to use Python to apply it to physics problems. Yeah, so the main file that's going to include all of the physics equations is going to be particleclass.py. The reason why is because this particle class is going to tell it tells the program how the particle moves. So that's where the laws of physics come into play. So just looking at an example of an equation being used here is in the calculation of the maximum height the particle reaches. So that's going to be right here and right here on the graph. So right here, I'm just going to highlight this equation. It's really important. It's a kinematic equation. And what it's saying is that the maximum height that the particle is going to reach is equal to the initial height plus the initial velocity in the y direction or in the up-down direction times the time minus 0.5 times the time squared times gravity. And so this is what contributes to the parabola shape in the graph, because you see time squared is what makes a quadratic equation. That's how you get your parabolas. So yeah, and that you can look through to find more uses of these kinematic equations. Again, you'll see this 0.5 times squared times gravity. So that's just an example of how we can use code to help us solve physics problems.